Good morning, boys. Today we're starting a new topic, algebraic equations. We've already done algebraic expressions, okay? Today we're starting the second part of algebra, algebraic equations. Now, as we had said earlier when we were doing the topic of algebraic expression, an algebraic expression is a mathematical statement consisting of, we talked about letter terms and or number terms. Examples of algebraic expressions are A to B, and the combination of both, a combination of letter term and the number term, like C plus 5. Okay? Now, an equation, right, is a mathematical statement, this time having an equals sign. The word equation, equate, the first part of the word equation, equate, is sort of known as equation because it has the equal, as you can observe, equal part of equate, equal sign, okay? As soon as you write down an equal sign, you create two sides. Side A is equal to side B. So we can recognize an equation from an expression because an equation has an equal sign. Thus, an equal sign creates two sides. Side A is equal to side B. Now, there are two types of equations. There are numerical equations involving number terms only. An example could be 2 plus 3 is equal to 5. It has an equal sign, so it is an equation. It has side A and it has side B, or it has side 1 and it has side 2. It has the left-hand side and the right-hand side. Okay, on the left-hand side we can find 2 plus 3. On the right-hand side we can find 5. Okay, now it has another type of equation is the algebraic equation, and we call it algebraic equation because it involves letter terms and number terms. For example, x plus 7 equals 23. On the left hand side we have the letter term x, we have a number term plus 7. On the right hand side we have the 23. Another example can be 2x plus 5 is equal to 17. We have a letter term 2x, we have a number term on the left hand side plus 5. On the right hand side we have a number term only, which is the 17. Now, when given an algebraic equation, normally we are asked to solve an equation. Now, what does solve mean? Solving an equation means figuring out, finding what the unknown value is. For example, what is the value of A, or what is the value of B, or what is the value of C. Okay, not the value of, for example, 2A, but the value of A. Not the value of 3B, but the value of B. Okay, we want to know what the unknown value is. If you remember the lesson on algebraic expression when we started the topic, we were talking about the unknown number of paper clips in the box. In one box, okay? So that is the unknown value, the unknown number of things in one bag, in one box, okay? Mela, solving means figuring out what the unknown value is. Now, how can we do this? We can do this by rearranging the equation until we have the unknown value all by itself on one side of the equation. For example, we rearrange the equation until it becomes A equals, okay, if we want to find the value of A, or B equals if we want to find the value of B, or C equals if we want to find the value of C. So we want to bring when we are asked to solve, our aim is to bring the unknown value on its own by itself on one side of the equation. It can be the left-hand side or it can be the right-hand side, okay? It doesn't matter. Now, it's important that when we rearrange the equation to bring the unknown value all by itself on one side, it's important to understand an important point. Which is this important point? This important point is that an equation is like a balanced scale. If there is the same amount of weight on each side, then the sides are balanced. I don't know whether you remember grandma weighing, for example, some ingredients to make a cake. She used to put, if she wants, for example, 250 grams of flour, she used to put the 250 grams weight on one side of the balance, okay, of the scales. On the other side, she prepared, for example, a paper bag, and she used to put flour in the paper bag until the scales are balanced. The two scales are next to each other, okay, precisely next to each other. As soon as they are precisely next to each other, she would know that she, for example, had weighed 250 grams of flour, because on one hand, on one side there would be the 250 grams weight, and on the other hand, on the other side, she would have the 250 grams weight in flour. Okay, so if there's the same amount of weight on each side, then the sides are balanced. Okay. So an equation is like a balanced scale, okay, when the scales are next to each other, okay. But if we add one weight to one side only, okay, then the two sides are no longer balanced. Mela, if grandma, for example, instead of putting in 250 grams of flour, she put in 300 grams of flour, and on the other side she would have the 250 grams of 250 grams weight, okay. Then she would know, if these scales are no longer balanced, then she would know that she either had put extra weight, extra flour, all right, or she still needs to add more flour to end up with a 250 grams of flour, okay. The scales would no longer be next to each other. If they are no longer balanced, the scales would no longer be next to each other, okay. If we add one weight to one side only, as you can see from the diagram, on one hand, on one side there are 3 squares, on the 3 cubes. On the other hand, on the other side there is only 1 cube. If we add more weight to one side only, then the two sides are no longer balanced. Now, this is the important point. So to balance them again, we must add the same weight, in our case, in algebraic equation, number, to each side. So if we add 2 to the left-hand side, we must add 2 to the right-hand side, okay? If we subtract 2 from the left-hand side, we must subtract 2 from the right-hand side, okay? It's just like grandma weighing flour, for example. If she puts in extra flour, she needs to add the weight on the right-hand side. If she takes off, if she takes out flour, then she needs to decrease the weight on the right-hand side. Okay? So to balance the scales again, we must add the same number, all right, to each side. When changing the sides, boys, when adding something to one side and when subtracting something to one side, does not mean that the sides need to look alike, okay? It just means that the two sides need to have the same value, Alright? For example, in the numerical equation 1 plus 1 is equal to 2, on the left-hand side, the 1 plus 1 does not look like the right-hand side, the 2, alright? They look differently, but have the same value, alright? 1 plus 1, the left-hand side, is equal to the right-hand because it has a value of 2. Okay, boys? Now, in the second example, 8 minus 3 is equal to 3 plus 2. Why are they equal? Because 8 minus 3 is 5. And 3 plus 2 is 5 as well. The two sides, as you can see, do not look alike, but they have the same value. On the left-hand side, the value of 8 minus 3 is 5. On the right-hand side, the value of 3 plus 2 is 5 as well. So since the left-hand side is equal to the right-hand side, then the scales are balanced, okay? That's how it should be. If you look at the diagram, 4 plus 1 on the left-hand side does not look alike, does not look like the right-hand side, which is 5, but it has the same value, okay? That's the important point. There's the same value on both sides. So we can say that the two sides are in balance, okay? Now, let's come to the examples. And the examples that we are going to do today is that we are going to have diagrams, pictures with a balanced scale, and we just need to write down the equation, okay? In fact, the exercise, the title of the exercise is form an equation which represents each of the following balanced scales. Since they are balanced, then we need to introduce the equal sign, okay? And also because it is an equation, okay? So the first one, on the left-hand side, I have x, okay? So let's write it down, boys. I have the left-hand side, LHS standing for left-hand side. I have the right-hand side of the balance scale, okay? On the left-hand side, I have a box with X. On the right-hand side, I have 5, let's say, marbles, okay? Since they are balanced, since the scales are balanced, so I can put an equals, and that is an equation, okay? Remember that an equation, the first part of the word equation has the first part of the word equals in it. So the equation is x equals 5, okay? Let's look at the second diagram now. So we have two sides of a scale of the scales. We have the left-hand side and we have the right-hand side. Now, on the left-hand side, okay, we have x and we have an extra 2 marbles. So with x, I'm going to add those 2 marbles. There are an extra 2 marbles. So on the left-hand side, I have x plus, because I'm going to add them with the x, the 2 marbles. On the right-hand side, I have 1, 2, 3, 4, 5, 6, 7 marbles. Since the scales are balanced, then I need to put in an equal sign. Okay, that's the second example. Now the third example, boys. It's very similar to the previous one. So, I have two sides, the left-hand side and the right-hand side. On the left-hand side, boys, I have an envelope with an X unknown marbles in it. On that side of the envelope with X unknown marbles, I have 3 loose marbles. So I'm going to add them together. So on the left-hand side, I have X plus 3. On the right-hand side of the scales, I have 1, 2, 3, 4, 5, 6, 7 loose marbles. Since the scales are balanced, I put in an equal sign. Okay, so that's the equation. X plus 3 is equal to 7. The fourth example, look at this now. On the left hand side, okay, we have the left hand side and the right hand side of the scales. I have two sides, left hand side, right hand side. On the left hand side of the scales, I have x and x and x and x and x, okay, and x, and I have another 2. On the right hand side I have 26, so I have this x plus x plus x plus x plus x plus 2 on the left hand side on the right hand side I have 26. Since the scale is balanced, so I can put in an equal sign. Now, when you have more than one unknown with the same letter, remember from algebraic expressions that we can collect them together. We can collect together terms, letter terms having the same letter. So I have an X missing here. Okay. So plus x plus x plus 2 equals 26. 1, 2, 3, 4, 5, 6 x's. Okay. Plus x. Okay. So we can collect terms having the same letter together, as we remember from algebraic expressions. So I have x plus x plus x plus x plus x plus x, and that gives me 6x. Remember from algebraic expressions. Plus 2 is equal to 26. I cannot collect the plus 2 with the 6x because the plus 2 is a letter term. Is a number term, and the 6x is a letter term, so I leave it like that. The equation is 6x plus 2 is equal to 26. Okay? I put in an equal sign because the left hand side and the right hand side are balanced. Okay? Now, last example, example 5. I have something similar to example 4 here. So, I have two sides, the left hand side and the right hand side. Now, on the left hand side of the scales, I have x. I have 5 boxes containing an x unknown marbles and 1 loose marble. So on the left hand side I have x plus x plus x plus x plus x plus 1. On the right hand side I have 3 boxes containing an x unknown marbles, and then with them on that side as well 5 loose marbles. Okay, so I have x plus x plus x plus 5. The scales are balanced, so I put in an equals sign. Since I have terms containing the same letter terms, both on the left hand side and the right hand side, I can collect those together. So x plus x plus x plus x plus x on the left hand side, it becomes 5x. Remember from algebraic expressions. And x plus x plus x on the right hand side, it becomes a 3x. Now, I have on the left hand side, I have 1 loose marbles. On the right hand side, I have 5 marbles. As we said earlier, since the two sides are balanced, then the equation is 5x plus 1 is equal to 3x plus 5. Okay? So boys, that is what we are going to do for today, so that we'll move slowly to be able to understand better. Okay? Your homework is very similar to these examples. You have the pictures and you need to form equations, okay? Just follow the lesson more than once if you have any difficulty. And try to work the lessons, examples on your own first before moving on to the homework, okay? To make sure that you've understood. Okay, that's all for today, boys. Good day and take care.